Episode 37B, Wendy and Residential Wood Burning, compared to Amazon Fire's PM 2.5 emissions. Wendy noted that the focus of residents against wood smoke emission particulates, RASEP, is on the health effects to near neighbors of living next to residential wood burning, in those hyper-localized areas where the source of particulate pollution, PM 2.5, is concentrated. PM 2.5, particulate matter of 2.5 micrometer size, is the perfect size to infiltrate the human lung, causing a cascade of human health problems. Wood smoke consists of 90% PM 2.5. Residential PM 2.5 monitors can be purchased by neighbors from Purple Air for less than $300, and their locations are put on the online Purple Air map, along with data uploaded every 10 minutes, available to the general public, and of course to governmental authorities. Neighbors of residential wood burners would like their Purple Air PM 2.5 monitor data to be used to regulate and shut down residential wood burning detected at neighbors' fence lines that exceeds the World Health Organization, WHO, standards of 5 micrograms per meter cubed or future U.S. standards of 8 micrograms per meter cubed. There could even be court-ordered monitoring using a neighbor-owned Purple Air PM 2.5 monitor as a breathalyzers, similar to car breathalyzers court-ordered for repeat drunk drivers, to turn off the ignition of a neighboring indoor wood stove when levels of PM 2.5 in a near neighbor's yard is exceeded. In this way, governmental authorities would not have to check the make and model of an appliance and would not have to rely on unreliable certification and other worthless assurances of levels of wood stove particulate emissions by the company that manufactured it. Purple Air monitors also provide data every 10 minutes 24 hours a day, and data can be downloaded from the map by governmental authorities the day after the PM 2.5 levels are exceeded during normal government working hours. Purple Air PM 2.5 monitors are so reliable and accurate they are put on U.S. Air Now smoke and fire maps alongside $100,000 Environmental Protection Agency (EPA) monitors, correlated to the EPA monitors with a simple mathematical formula. But to publicize this, it is necessary to point out that living hyperlocalized next to a residential wood burner is essentially the same as living next to wildfires in the South American Amazon basin. Amazonian wildfires also produce large amounts of PM 2.5 or particulate matter of 2.5 micron size. The difference is that, with PM 2.5 monitoring, the pollution can be preempted by shutting down the hyperlocalized residential wood burning, but control of wildfires cannot be as easily controlled. It appears that less human-initiated pasture and cropland burning after forest clearing could exert some control over the wildfires in the Amazon basin of Bolivia and Brazil. The article that Wendy noted stated that on September 5, 2022, the Moderate Resolution Imaging Spectroradiometer, MODIS, on NASA's Aqua satellite acquired a natural color image of smoke over parts of Bolivia and Brazil. Thick smoke was emitted from Bolivia's El Beni and Santa Cruz districts, where forests receive less rain than other parts of the Amazon basin. The smoke streamed north and mixed with plumes from fires burning in rainforests in Brazilian states, including Acre, Amazonas, Rondônia, Para, and Mato Grosso. Fire activity in 2022 occurred along highways, notably BR-163 and the Trans-Amazonian Highway in Para and Amazonas. The thickest smoke plumes amid the heavily forested, green, areas rise from deforestation fires. These are lit to dispose of piles of leftover wood, often months after forests were bulldozed. Forest clearing for ranching and farming is common. Smaller smoke plumes in cleared, agricultural areas, brown, are grassland fires lit by ranchers and farmers on cattle pastures or croplands. Human-caused deforestation and pasture fires escape control and spread unchecked. In wet parts of the Amazon, in the western and northern parts of the basin, this can lead to understory fires that smolder and spread along the forest floor. In drier areas, including the Chiquitano forests, Beni savanna, and Chaco forests in Bolivia, fires spread more quickly, burn hotter, produce more smoke, and consume the forest canopy. Brazil's National Institute for Space Research, INPE, uses MODIS observations to monitor daily fire activity in the Amazon. INPE scientists also maintain a record of MODIS fire detections that spans decades. The agency reported 226,677 Aquamodis fire detections throughout Amazon basin countries between January 1st and September 12, 2022. Argentina, Bolivia, Colombia, Paraguay, and Venezuela all had more than 10,000 fire detections. Brazil had 117,436. Brazil's fire count in 2022 is the most since 2010. We have seen plenty of fire activity in recent weeks, said Alberto Setzer, a senior scientist at INPE. The fire season in the southern Amazon doesn't usually wind down until October or November.